Chemical bonds can be classified as ionic and covalent. In ionic compounds, as an example we have here is a sodium chloride. Okay, sodium is positively charged, chloride is negatively charged, and sodium, as you know, has one valence electron, and that one valence electron, because it is a metal and capable of remaining as electropositive in nature, donates its valence electron to chlorine atom. The half-headed arrow tells us that transfer of one electron occurring from one direction to the other, one place to the other. By losing one electron, sodium acquires a positive charge and it attains, the sodium plus ion has an electron configuration similar to the previous noble gas on the periodic table, which is neon. By taking an electron from sodium, chlorine is now chloride anion. With one electron coming from sodium, it has attained an octet, and the electron configuration of our chloride ion becomes similar to that of argon, which is the next noble gas on the periodic table. So both the process of losing electron from sodium and gaining electron by chlorine, they are both favored, and so it forms a stable compound. The nature of bonding between the chlorine and sodium here in this is purely electrostatic attractive force between positively charged sodium ion and negatively charged chloride ion. On the other hand, a covalent bond is formed by sharing of two electrons, one each coming from the two participating atoms in making of the bond. So in this case of ammonia, we have hydrogen with one electron in its valence shell that's being donated into the bonding system with the lone electron coming from one of the 5 valence electrons in the nitrogen atom. Same way, this process is repeated 3 times. I'm using half-headed arrow to signify the transfer of one electron. So we have 3 hydrogens coming in, each bearing one electron, and then 3 other electrons are donated by nitrogen to form a bond with each of these hydrogen atoms. Now the nitrogen has acquired an octet. An electron configuration with that octet arrangement is going to be similar to the electron configuration of neon. So it is stable. Hydrogen is an exception for the octet rule. We can draw the Lewis structure either one of these 2 forms. A special class of covalent compound is called the coordinate-covalent bond, in which the bond, which involves 2 electrons, okay, the 2 electrons are donated by the same atom, not by these 2 atoms like this in this case of a covalent compound like ammonia. Here the two electrons residing on the nitrogen of ammonia is donated fully, okay, as you can see from the fully formed arrow going towards hydrogen, meaning the 2 electrons are donated to make bond. So when both the electrons come from one atom to form a bond between the 2 atoms here, then that kind of bonding is called coordinate covalent bond. It is covalent in nature because ultimately it'll look like it's mutually shared, but originally the 2 electrons that make up the bond would come from one of the 2 atoms. So now in this case ammonia, nitrogen provides the 2 electrons to form a bond with hydrogen in water, and as a result this hydrogen cannot have more than one valence. So the electron that was originally present in hydrogen that was given to form a bond with oxygen in water molecule is removed and it goes into the oxygen. I'm going to use a half-headed arrow, or I would rather use a full-headed arrow, meaning that both the electrons that make up the bond are going into the oxygen's valence shell. So as a result, you see here you have 8 electrons surrounding the oxygen, and because this oxygen has acquired an electron from hydrogen in water molecule, this has got a negative charge, and this bond between nitrogen and hydrogen is formed as a coordinate covalent bond, in which the nitrogen donates one of the pair of electrons to form a bond with hydrogen. This electron lost produces a positive charge on nitrogen in ammonia. So this becomes ammonium ion, and the compound as a whole is ionic, but the bond here between the nitrogen and hydrogen in this case is a coordinate covalent bond.